Hi everyone, welcome back. Today the remaining part of the properties of Laplace transform will be seen today. So the property number 3 is multiplication of powers of t. Okay, so we know that L of f of t is what? F of s. This is the basic equation. We know that. So if I took L inverse of f of s means I will get this answer f of t, right? This is for your reference. Like if I say L of 1 will be equal to 1 by s means I can say L inverse of 1 by s which is equal to 1. Just this is for your inverse because it may be asked in the inverse Laplace transform. Okay, so this is the equation. So in that equation I'm gonna multiply t here. So L of t into f of t means the answer will be minus differentiation of this f of s. Okay, so we need to put minus here and then we need to differentiate it like minus f dash of s. Okay, so here you can see here, so the general equation will be like L of t power n into f of t. If I put n here means I can write this as minus 1 the whole power n. So this minus 1 the whole power n into d power n by ds power n into f of s. So this is the general equation. For example, I'm just giving a question here. L of t into cos 2t the whole power n means, the whole square means, so we can see here the t power is what? 1. So they have given the whole square. So I just took L of t square. I'm just took the square for separate one, t square and cos square t 2t. Okay. Then this is like in this form, L into t power n into f of t, right? This is in this form. So I can easily write this as minus 1 the whole power 2 d square by ds square into, just for this thing I'm just writing L of this part f of t. Okay, right? You can see here L of f of t is what? F of s. So I'm just writing this as L of f of t. This one is f of t. So L of f of t, which is nothing but f of s. So I just write in this way. So we're gonna solve this thing. And here there comes one formula, cos square theta, which is equal to 1 plus cos 2 theta. Cos square theta means 1 plus cos 2 theta by 2. This is a formula. Just apply this formula here. So 1 plus cos 2 theta means what? 4 theta. 2 into 2, 4. So 1 plus cos 4 theta by 2. So I'm just wrote all these things here. After that, half of, I'm just taking this 2 outside. This 2 as outside. So half of, and minus 1 the whole square will be 1. So I'm just taking this 2 outside and this become 1. So half of d square by ds square into, so this is the thing here, like 1 by 1 plus cos 4 theta. Okay, so we just gonna do L of 1 plus cos 4 theta, right? So we're gonna do that. So after this we know that L of 1 is what? 1 by s, right? So 1 by s. L of cos 4 theta is what? 4t is what? The formula is s by a square by a square plus a square, right? So here a is 4. So I'm just write s by a square plus 16. Yes. After this I'm just differentiate this two things by one time, like one derivative. So half of d by ds, I'm just gonna differentiate it by one time. So minus 1 by a square. We know that 1 by x. If we differentiate 1 by x means it will become minus of 1 by x square. So 1 by x, if we differentiate 1 by x, it will become like minus power முன்னாடி கொண்டு போய் powerல ஒன்று plus பண்ணணும். So if I say 1 by x means 1 is the power, right? So I'm just going to take this power up. So it will become 1 by x. I need to add plus 1 to the power. So square and the minus. So minus 1 by x square. Likewise, here you can see here 1 by s will be like 1 by s square. So I just differentiate this term. After that plus, this is like u by v, right? So what is that u by v means? We need to do u dash v minus u v dash by v square. So this is a formula. Okay, this is a formula for the differentiation. So I am just writing u dash v, right? So here I am just taking this as u and this as v. So u dash means this is u and this is v, right? So u dash means s will become 1. S will become 1. 1 into this term minus u, next v dash 2s by this square. So v square. So after that, which is equal to 1 by 2, and again we need to differentiate this term. Okay, so I'm just differentiating this term like power முன்னாடி கொண்டு போய் powerல ஒன்று add பண்ணு, right? And we need to change the signature. So minus will become plus and we need to bring this 2 upside, 2 by s power 3. This is the thing. Plus here again this u by v. So this is u term, this is v term. So there is 2 term here. So just simplify it. You can see here s square plus 16 minus 2s square. So this term will become s square minus 2s square will become minus s square, right? So minus s square plus 16. So this is the term. This is the u term and this one is v term. So you can see here u dash, if I differentiate it means it will become minus 2s into v, s square plus 16 the whole square. This is v minus of, okay, u dash v minus u, I just wrote this u here, minus s square plus 16 u and then v dash. V dash is what? If I say x square means bring the power before and minus 1 to the power and then base, you need to differentiate it. Power முன்னாடி கொண்டு powerல ஒன்று minus பண்ணிட்டு base differentiate பண்ணணும். So you can see here I just bring the power before 2 and then this is the base. So base power minus 1 because 2 minus 1 is 1. So 1. Power முன்னாடி கொண்டு powerல ஒன்று minus பண்ணியாச்சு. Then base differentiate பண்ணணும். Base is what? S square plus 16. So this will become 2s. Okay. So u dash v minus u v dash. So up to that I have finished. By v square. Already there is a square here. So v square means it will become 4. So after this you can see here half into 2 by 3. 2 by s cube. Right. Minus of. I'm just taking this 2s and this 2s as outside. Okay, and the minus, here is minus, here is 1 minus. So these 2 minus, I'm just taking this minus as whole, minus of 2s. I'm just taking this 2s as common. 2s into s square plus 16, okay, s square plus 16 square plus this term and then 16 minus s square. So this term into 2 into this term. Okay, so I just took 2s as common here and you can see here these 2 terms, it's square and this one is like 1 plus 6. Okay, so if I took this term as outside means it will become, it will get cancelled, right? So here is square and here is 1. So I'm just taking only one term like a square plus 16 as outside means this will become 1 and this will get cancelled and here 4 will become cube. Okay. Okay. Then I am just taking these 2 terms as outside and remaining part I have wrote here. You can see here s square plus 16 plus 32. Okay, so a square plus 16 plus, so this 16 is 16 minus a square. I'm just multiplying this 2 here, 32 minus 2a square. Okay, after that you can see here this a square and minus 2a square will become minus a square, right? And these two parts will become 48. So minus a square plus 48 will be here. And in this term I am just multiplying this 2 here and here. Okay, afterwards the answer will be like this term. So 1 by s cube plus s by a square plus 16 the whole cube into a square minus 48. Okay, you can see here this 2 will get cancelled if I multiply 1 by 2 inside. So this will be the answer. Okay, so next property is what? Fourth property, change of scale property. Here we are changing the scale. Okay, so this is a term, general term. L of f of t will be equal to f of s, right? If I put a inside means f of at means it will become 1 by a into f of s by a. So this is a property. Okay, so let me say find Laplace transform of e power at. So you can see here the function is like at into sin at by using the change of scale. They have asked one question. So L of f of at will be equal to f of s by a. I am just writing this a as a whole. And I am just writing this f of s. Here is what? S is what? S tends to s by a. So in place of s I am going to write s by a. So I am just writing this as in this form. So what is f of x? F of t here? E power t into sin t. So I am just first writing this is what? F of at. So this whole term is what? F of at. So I am just writing only for t. So f of t is what? E power t into sin t. So I am just taking for this alone. So you can see here L of e power at, okay, will be the answer is 1 by s minus a. If it is f of e power t means 1 by s minus 1, right? So we have got L of et, this one, and then the remaining is what? L of sin t. L of sin t, okay, L of sin t is, but in this thing we just gonna put s tends to s minus 1 because after simplifying it we know that L of e power t is what? 1 by s minus 1. So in place of s there is s minus 1. So the same here, L of f of t like L of e power t into sin t, this term. So this term is what? 1 by s minus 1. So in place of s we know we're gonna do s minus 1. So sin t's formula is what? In sin t's formula we're gonna do s in terms of s minus 1. Okay, sin t is what? 1 by s square plus 1. So in place of s we're gonna do s minus 1. So after substituting this will become like f of x. So for L of f of t we have found f of s. Here L of f of at means what? This term. So 1 by a into f of s by a, right? So f of s we know. F of s is this term. So in place of s we're gonna do s by a. So I'm just substituting s by a here. After simplifying you will get the answer for L of f of at. Okay, first simply take f of t, then find f of s. Afterwards you can get, you just compare with this with the formula. In the formula you can see here f of s they have written s by a, right? Like s tends to, where it is, s tends to s by a. This is in the formula. So I'm just took s by a as s, okay, and then simplify it. You will get the answer. Okay, next fifth property is what? Division by t. Okay, this is, or you can say it as integration of Laplace transform. So this is general form. F of t, L of f of t will be equal to f of s. If I put by t here, division by t, you will write this as in the integration. Integral s tends to infinity, s to infinity, f of theta into d theta. This is the term. So, this is the fifth property. Okay. So, they have given one function here, 1 minus cos t by t. First, we need to take what? F of t. So, I am just taking only f of t as 1 minus cos t. So, afterwards, you can see here L of 1 minus cos t. So, L of 1 is 1 by s and cos t is what? 1 by s square plus s by a square plus 1. So, this is what? F of s. But here, we need to find L of f of t by t. So, this term. And I am writing, we know that f of s is this term. So, I just wrote f of theta. So, in place of s, I am going to write theta here in terms of integration. So, it will become like integral s to infinity 1 by theta minus theta by theta square plus 1. This is f of theta. I just wrote all this thing. Afterwards, I am just taking s to infinity s b. So, b tends to infinity. I am just replacing infinity by b. So, I am just adding limit here. Limit b tends to infinity. So, after this, solve all these things. Like, so, here 1 by theta minus, I am just giving 2 here, multiplying 2 by 2. Why it is? This is theta square. If I differentiate this term, it will become 2 theta, right? So, I am just multiplying it by 2 and I will get 1 by log. This one is log theta. If I differentiate theta, it will become 1. So, log of theta minus this half. Just take this half as 1. 1 by 2, half. And then log of this term will become 2 theta, right? So, log of theta square plus 1. If I differentiate this term, it will become 2 theta. So, log of this term. Okay. Afterwards, just put log as common. And here it is minus. So, I am just dividing these two terms. And this half will become here. So, it will become root, right? So, theta by theta square plus 1, the whole part 1 by 2. Okay, this is the term. So, afterwards, apply the limits here. I am just applying b here and then yes. You know that b tends to infinity. So, this term will become 0 and only this term will be remaining 1. Okay. Afterwards, so this is the term. Okay, there is a minus here, minus of this term, right? So, I am just making this as plus here. So, this will become reverse, root of s square plus 1 by s. So, the answer will be this one. And the last property, sixth property is by integral. Okay. So, f of s which is equal to L of f of t. So, this is the general term. So, L of f of t will be equal to f of s. So, this is here. Okay. So, in terms of f of t, I am just taking an integral. So, integral of 0 to t, integral, the limit is 0 to t, f of t into dt. So, this is a term in terms of f of t. And then f of s by s, this is the property here. So, they have given one function here, you can see here, this is in terms of integral. So, after that, you can see here, I just need to find the inside part, L of a sin at. So, this will become like a by a s square plus a square. So, I have found f of s here. Okay. Yes. So, f of s here. After that, so f of s is this one. So, f of s by s will be I will get this form. So, this form is like, for this integration, I will write it as f of s by s, right? So, I can write this form as this term which is equal to 1 by s of the f of s, right? So, this is the answer. So, it's dead easy and so simple. Let's move on to the Laplace transforms of derivatives and integrals. Like this is a theorem 1, theorem 2. Okay, for the derivatives and integrals. Okay, if f of t is continuous for all t greater than or equal to 0 means, I can say this f of t is continuous means f dash of t is also a continuous one. So, L of f of t will exist means the limit will be, the answer will be like limit t tends to infinity. So t is what? Tends to infinity into e power minus st. F of t will be equal to 0. E power infinity is what? 0. So this term will become 0 only if L of f of t exists. Okay. So L of f of t will be equal to s into L of f of t minus f of 0. So we can write this as s into this one f bar f of s minus f of 0. So if this is exist means this term will become 0 and this term I can write this like this. Okay. Next, the theorem 2. If f of t and its derivatives f dash of t or f double dash or up to this or all or continuous means, then for all t greater than or equal to 0 means, then I can say f per n t is also a piece of continuous. So the formula will be like L of f of f per n into t. F per n into t will be equal to s per n into L of f of t minus s per n minus 1 into f of 0. Again minus s per n minus 2. So n minus 1, n minus 2. The first term is L of f of t. After that f of 0, f dash of 0 up to f per n minus 1 the whole part 0, like into 0. Okay, f per n minus 1 into 0. So this is the function f of 0. Okay, the power is n minus 1. And the third theorem is what? Laplace transform of integration of f of t. So if L of an integration is there 0 to t f of u into du means I can write this as f of L of f of t by s, because this is like f of s by s, right? So the same term here. Take g of t as this term. So I am just taking this as g of t. I am just going to differentiate this term g dash of t in terms of L of t. So this is like the first theorem. You can see here the first theorem is what? L of f dash of t means we can write this as s of L of f, like s of L of this term without derivative minus f of 0. So I am just writing here L of, so s into L of this term without derivation. So this term minus g of 0. Okay. So where g dash of t is f of t, if I write g dash of t is f of t, so I can write this as L of f of t which is equal to s minus g of t. So this term will become 0. So this is the thing. So we can easily write L of g of t will be equal to this term by s, L of g f of t. Okay, this term and this term. Okay, if I say g dash of t is f of t means I can write this as L of g of t will be equal to L of f of t by s. Okay, and there comes another sum, L of f of 0 to t. So they have given one integral part. So I am just writing this as in this form. So f of s by s. Okay, so I can write this as f of t. So f of u, this term, okay, will be equal to f of t, right? We have, as we said, like this term, inside term g dash of t will be equal to f of t. So I am just saying this f of u as this one. So I am just taking like this. So what is L of sin t by t? What is L of sin t by t? L of f of t will be equal to L of sin t, right? So the answer is this one. So if I put by t, so I need by t, right? So if I put by t means I can write this term in the theta term. So this comes in the property, right, by t. So I can write this term as in the f of t. So integral s to infinity. So f of theta is what? F of s. So in place of s I am going to write theta square. So 1 by theta square plus 1 into d theta. So this is from the property. Okay, from property. Okay, so I'm just writing this term. After integrating it, I'm just writing this infinity as b. So limit b to infinity. So this term is what? Tan inverse of theta. So tan inverse of theta s by b. So tan inverse of infinity what? Pi by 90. So 1 by pi by 2 this term. So we have got this as this term. So L of tan t by t will be equal to cot inverse of s, because 90 minus tan theta will be equal to cot inverse of s, tan inverse. So cot inverse. Okay. So from the first one is what? We have wrote this as this term L of f of 0 to t. So integral 0 to t sin x by x into dx will be equal to this term L of theta f of t by s, right? So I'm just found this one. By s will become this term, right? I'm just bringing cot inverse of s by s will be this term. Okay, let's see another one dimensional wave equation. So first one, I'm just using the method of separation of variables. Okay, so you can see here they have given one question here, 3ux plus 2uy will be equal to 0. So this is like u, and they have given one thing, u of x comma y, like x comma 0 will be equal to 4x power minus x. So they are saying y as 0, then it will become this function. So we know that I'm just assuming u of x comma y will be equal to x of x into y of y. Okay, this is a common term. So in this thing, I'm just writing u which is equal to x into y, right? So I need to separate the x and y. So u which is equal to x into y. Okay, so I'm just taking this as one equation. So I'm just taking with respect to y, with respect to x, with respect to y. Differentiate it with respect to x means x dash of y. With respect to y means it will become x double x into y dash. So I can easily write this in an equation. Like you can see here, 3 into ux with respect to x with respect to y. So x dash of y, y dash of x here. So I can write like this. I need to just separate x, y. So what can I do? So I'm just bringing this term here. After that, I'm just making the x as one term and y as another side, which is equal to k, because I'm going to integrate it. So I'm just taking this two things as constant k. So with this thing, x dash of x which is equal to k by 3. So I'm just integrating it. So if I differentiate this term, it will become like this. So log of x plus, this is constant, into x plus log of c. I'm just taking this log because at final I can get like c as a single term. So I'm just bringing this log here. Likewise here log y which is equal to the constant into y into plus log c2. Okay, this is a term. After that, just simplify, just take log here. So it will become minus. So x by, I'm just gonna write this in division, x by c1, log of x by c1 which is equal to k by 3 into x. The same wise here. And you can see here, now you can take the log here. So I can take the log on the other side means it will become e, right? So x equal to e power k by 3 x into c. This term will be multiplication here. So if I don't put log c means I will get somewhere some complex term here. So I'm just gonna put simply c, so that I'm just apply log in the c, in the constant. So after that you can see here I have got x and y terms. I'm just substituting here. I will got the u term. So u is the 1. Afterwards they have given u of x comma 0. I have to put y as 0 here. Then the answer will be like this. So from this I can easily get c as 4, and from these two terms. So these two terms, the base is same, e. So kx by 3 will be equal to minus x. So k will be minus 3. So I have got these two things. So just substitute in the u equation. Okay, so the required solution will be like this. Substitute in u of x comma y. These two things. You will get the answer. Okay, let's see the derivation. So derivation of stretched string for one-dimensional wave equation. Okay, this is a derivation. How can we derive the one-dimensional wave equation? Then comes the heat. Okay, up to this differential equation is completed. Okay, let's see this. Consider a uniform elastic string of length L stretched tightly. It is stretched tightly between the 2 points O and A, and the displaced slightly from its equilibrium position OA. Let us say this OA has equilibrium position. So this is like a string. I am just tightly this is tightly stretched, okay, from these 2 points. So OA. Somewhat there will be a displacement. There will be a displacement with respect to this equilibrium position OA. Okay, that's the thing here. So we just taking the end as O. You can see here the end as O. Okay, so the origin as the origin. So O as the origin and OA in the x-axis. So this one is in x-axis. So perpendicular to this OA, there will be one line, that is OY. Okay, y-axis. Okay, that's the thing here. So perpendicular to OA, through the origin, there is y-axis. So this is the string. Okay, so there in this curve, there occurs two tensions. This is like a tangent here to the curve. Okay, so we shall find the displacement of y. So we are gonna find the displacement y. You can see here this P is what? P1 cos alpha and T1 sin alpha. Like this angle is alpha, so I am just writing it in alpha, and this angle is beta, so I am just writing it in beta. There is two things here, cos and sin. So cosine, cosine. Okay, this is tangent 1 for the tangent 1, this is for the tangent 2. Like this is tension 1, tension 2. Okay, so that occurs 2 points PQ. And I am giving some assumptions here. The motion takes place entirely in the xy plane, and each particle of string moves perpendicular to the position of OA of the string. So they have given the entire motions will be in this part alone, like xy plane, entirely in the xy plane, and each particle of strings moves perpendicular to the position. So each particle is moving perpendicular. This is perpendicular to the equilibrium position. And the string is perfectly flexible. This is flexible and does not offer resistance to bending. So it is flexible means we can easily bend this string. And the tension in string are so large that the force with respect to weight will be neglected. Like the tension is a large one. So this string has more tension. So we can easily neglect the force with respect to weight. Okay, so weight nala vara force we can neglect it. Okay, then the displacement y and the slope will be dou y by dou x or small. So higher powers on these things will be eliminated. Okay, these are the assumptions. Let's take m as mass per unit length of the string. So this is the mass per unit length of the string. Consider the motion of an element PQ of length del S. So I am just considering the length as smaller one, del S. Okay. Next one. Since the string does not offer resistance, we know that the string is a flexible one. So this is a flexible one, so it does not offer resistance to bonding. So the tension we know that T1 and T2. or at 2 points. There are 2 points. We have seen this in graph, right? So there are 2 points, and at these 2 points there are 2 tensions occurs to the curve. There is no motion in horizontal direction. So there is no motions in the horizontal direction. So we can directly fix the motion only in the vertical direction, like only the x components. So these, the cos or the x components, right? The cos or x components, and y is sine components. You can see here in the graph, the x1, the x components is cos, right? This one is cos and this one is sine. Y component is sine. So I am just fixing the x components alone because there is no motion in the horizontal direction. Okay, so I am just fixing the x components. So T1 cos T alpha plus T2 cos beta, which is equal to T. So I am just bringing the x components alone. And mass of the element is what? M into del S. So this is the length, right? This is the length. So for unit length, the mass will be M by 1 length, means unit length 1. So mass of the particular element PQ means the length they have given, so mass into length. Okay. By Newton's second law, the equation of motion in vertical direction will be, we know that Newton's second law is what? F is equal to ma, mass into acceleration, force. So I am just writing this force in terms of y, like net force in terms of y components. So y2 minus y1, right? In terms of y components, I'm just writing this force as in terms of y components. y2 minus y1, this is a net force, which is equal to, we know that mass is what? M into del S, mass into the length, into acceleration. So with respect to y, with respect to t, so y with respect to t means this will become velocity. If it is acceleration means I can easily write dou square y by dt square, dou t square. Okay, so m into del S into this term will be equal to the force. This is y component. T2 sine alpha minus T1 sine, T2 sine beta minus T1 sine alpha. So this is a term. So I am just dividing this term by t. Okay, t is what? This thing. So I am just writing m del S by t into d square y by dt square. So this left hand side is finished. In the right hand side, I am just writing the remaining part of this. Like this is y term, right? So I am just writing the x term. Okay, as in the denominator. Okay, like T1, T2 sine beta by this one. So this is sine means this will cos. Sine means cos. Okay, I'm just writing only the x term here. Okay, so if I do so, I will easily get, this one is T1. So T1, T2, 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 T1, T2, T1. So I'm just writing, this is y. So I'm just writing the x term, y and x term as in the denominator. I will easily get it as tan, because this t will get cancelled and sine by cos is what? Tan, right? So the left hand side is same, tan beta minus tan alpha. So I can write this as this term, like I'm just bringing this term here, t by m into del S. So here del S is approximately equal to del x. Okay, I'm just write like this, approximately equal to del x. And we know that tan beta means tan beta, tan alpha. Tan means that is nothing but slope of curve. So this is 2 points, right? So slope of curve at a point x and x plus del x. So this one is, you can easily get it from the these two things. So x and x plus del x. So this is the slope. So these 2 points. So I'm just going to find the slope for these 2 points. We know that slope is what? Del y by dou x. So as you can see here, the displacement is y and slope is what? Dou y by dou x. So I'm just writing this term. So we can easily write this thing as m into, I'm just writing only m because this is with respect to dou dou s will be approximately equal to dou x, right? So I'm just writing t by m into the whole term, like this term tan beta is what? This term with respect to x plus dx, del x, again minus this term d dou y by dou x with respect to x. You can see here these are the points. I'm just writing the points here, and this is slope. So tan beta minus tan alpha by del x. So this is nothing but del x. So del s is approximately equal to del x, right? So I'm just writing as a whole. So these terms will become like, these whole terms will be dou square y by dou x square. If del x is equal to 0 means I can write these whole term as dou square y by dou x square. So you can see here in the left hand side is what? Dou square y by dou t square, which is equal to this term. So I can write this term as c square. Okay, I can write this term as c square. So in place of this term I will write c square. This is the 1D wave equation. Okay, next thing is there occurs some boundary conditions, right? So the boundaries are if x equal to 0, y equal to 0. If x equal to L, again the y equal to 0. These are the boundary condition. If the string is made to vibrate by pulling it into a curve, so by pulling it into a curve, it tends to vibrate means the curve will be like y equal to f of x. Then release it after pulling it into a curve and then release it. So there will be then there will be initial conditions. Like what is the initial condition means if time is 0, the y will be f of x. If time is 0, the first differentiation of this y will also be equal to 0. Okay, so initial conditions are what? T equal to 0, y equal to f of x. T equal to 0, the same time t equal to 0, y dash will be 0. That's the thing here. So we need to find the solution for the wave equation. Let's see that. This is also somewhat a derivation. So the wave equation, we know that dou square u by dou t square will be equal to c square into dou square u by dou x square. So in terms of with respect to t and x, so c square as a constant in the center. U which is equal to x into t. So I am just taking u as x into t, right? So differentiate it 2 times. So dou square u by dou t square. So t is double dash. Here x is 2 square, means differentiate with respect to x. So x has 2 derivatives. So I am just writing these 2 terms in this wave equation. So the wave equation will become x t double dash, which is equal to t square x double dash t. Okay, so just separate it. Separate t and x, like x and t. I just separate all these things. So you can see here I am just taking as k. The same applies here. Just take the 2 terms as k. After that you will get an equation like this. Okay, x double dash minus, this will become into, so minus kx which is equal to 0, and t double dash minus k c square and t, right? These term will become minus. So if it comes here means it will become minus, which is equal to 0. I have got 2 equation in terms of k. So next thing is what I need to find the k and c values. So I am just taking 3 cases here. Like if k is positive means I am just taking it as p square. K which is equal to p square. Okay, I am just writing this u which is equal to what? X into t, right? So this term is x and this term is t. So you can see here if k is positive, if I put anything as positive means we can write this thing as d square minus 1 which is equal to 0. If I put this one as positive means I will get d as what? 1. So d square equal to 1 and d which is equal to plus or minus 1. So I can easily write this as plus 1 and minus 1. So I have, if I put this thing as plus means positive means I will get d square minus 1 which is equal to 0. So d equal to plus or minus 1. So I can write this as in C complementary function like C1 e power px plus C2 e power minus px. So this is a term. This one is x. For t term, the same applies here. If you consider this as constant, means you will get d square minus c square, which is equal to 0, right? So d, which is equal to plus or minus c. So the same applies here. C and t. Sorry, t will also come. So we can say this as cpt minus cpt. So plus or minus, sorry, here is p. I am just taking k as p square. So this one is p. So plus or minus p. Same applies here. This is in terms of t. Okay. So in terms of x is in terms of x and t is in terms of t. So I am just writing t because t is a function of t, right? So d, which is equal to plus or minus c. D square, which is minus c square, will be equal to 0. So d equal to plus or minus c. I can write like this. So this is the first case. And second case, if I put k as negative, means minus p square, then the equations will become c1 cos px plus c2 sin px and c3 cos cpt, because there comes a I function here. So plus or minus pi, this will be the function for x, and for t plus or minus cpi, then only we can write like this. So beta functions only here. Okay. If k equal to 0, means these things is not possible in the real physical. Okay. This is somewhat, this is possible. So case 2 is correct. And then if I put k equal to 0, means I will get like this. So this is also not possible. So I am just taking only the case 2 here. What is the boundary condition? As I told you, u is 0, means 0 comma t, which is equal to 0. U which is equal to L comma t, which is equal to 0. So I am just applying these things here. We know that this is the equation, right? So if I apply 0 comma t, if I apply 0 here, means it will become c1. 0 means it will become 0. So c1 into the whole term. There is no x here, so we can't apply it. And in place of t, I am just applying just a t. So c1 into this term, right? c1 into this term. This whole term will be not equal to 0, which is equal to 0. This is the boundary condition, which is equal to 0. So this whole term will not be equal to 0. So I can easily say c1, which is equal to 0. And I am just applying the second term here. So I need to put L here. But here you can see in the first condition I said c1, which is equal to 0. So just omit this part and this part into the whole term. So this is the condition. We know that this whole term will not be equal to 0. And c1 is 0. So c2 will not be equal to 0. So this term will be equal to 0. I am just equating this term. So PL, which is equal to, when we know that sin n pi will be equal to 0, right? So sin n pi will be equal to 0. So PL is what? N pi. P equal to this term. This is nothing but the eigenvalue. And the function is what? Sin px. If I said sin px, means p is what? N pi by L. So n pi by L into x. This term is what? Eigenfunction. Okay, by using the boundary condition, we have found the equations. We have found the things. Just substitute u of xt. So here you will get the answer. And here you can know that C2, the same thing here applies these three things. Okay, the same equation here. And you know that I am just multiplying the C2 here. So I will get C2 C3 C2 P4. So in place of P, I just applied P equal to N pi by L. So that equation will become this. So I am just multiplying this constant everywhere here. So you can know that C2 C3 C2 C4. I am just taking this term as AN, this term as BN. Okay, for N greater than 0. So I can easily write this as a summation of N, which is equal to 1 to infinity. this term plus this term into the sine term. So this is the solution of principle of superposition of solutions. So this is the solution of wave equation. This is principle of superposition of solution. Okay, and I am applying the initial condition, and the another thing is here there is an initial condition. Initial condition is what? If u of x comma 0 means it will be f of x. If ut of x comma 0, it will be 0. We know that y is equal to 0 means y equal to f of x, first condition, t equal to 0. If t equal to 0, the same y will be y dash will be 0, right? So this is the thing I have applied here. So by doing so I am just applying the second condition in this equation. Okay, second condition is what? Ut of x comma y. Ut is what? We need to differentiate this term with respect to t. If I do so and apply these two conditions means t equal to 0, I will get like this. Okay, in this term I have found bn which is equal to 0. Again apply the second term. So bn is equal to 0. So substitute this bn in the first term. Okay, this equation, and you will get one equation like this. Okay, you can see here this is the solution. So in this thing I am just taking this an. There is one undefined one is an, right? So for that purpose I am just taking f of x which is equal to this term an and sine term. I am just leaving the cos term. This is f of x means you can see here this is the half range Fourier sine series of f of x. So this is a half range Fourier sine series. So if it is like this means I can easily write this an, because in the Fourier series an will be equal to 2 by L integral 0 to L f of x sine n pi x by L into dx. So I have got the an here. You don't need to apply the first condition, just apply the second condition, you will got this formula. This is the solution and this is the an equation. Okay, next comes the one dimensional heat solution for the rod. Okay, so here comes the derivation. So consider the thin rod in which the heat is flows in the x directions only. There is no y, the heat is not flowing in the y direction. Okay, only one direction, x direction. The temperature in the rod is same because the rod is thin, right? So the temperature is same at all the points across any cross section of the area. Okay, area of the rod. So any section, any area, there will be same temperature because the rod is thin. So that's why I am taking the thin rod. Let u of xt will be the temperature at distance x from origin at time t. So in time t, in time distance x, we are taking u of xt will be the temperature, and consider a segment of bar like del x as the thickness between x and x plus dx. So I am just saying this thin rod. Okay, so this is x and this point is x plus del x means I am just taking the thickness at some center del x. So del u will be equal to the change in temperature because u is what? Temperature. So del u means change in temperature in the segment del x. Okay, these are the things. So the amount of heat crossing the section at x in time del t. So first we are taking for the section x, amount of heat in section x for time del t will be given by R1, which is equal to minus Ka into the term del u by del x, dou u by dou x, the whole x in terms of x because the section at x into dt. Okay, so this is for time, this is nothing but the time, and this one is the temperature with respect to x. Okay, this is the area. Okay, these are the things. If I want the amount of heat, this is heat. Okay, if I want the amount of heat at section x plus del x means what? The same thing, x plus del x. Okay, so if I minus these things I will get the del x only alone for the del x. So the amount of heat regained in the typical section del x, I want the del x means I am just gonna minus these two things. So R1 minus R2. If I do so, I will get for del x, right? So you can see here I am just taking K as constant here as outside, and this thing is proportional to the mass of body and change of temperature. So this R1 minus R2 is proportional to mass and change of temperature del U. So I can easily write as I am putting a constant here, sigma. So R1 minus R2, which is equal to sigma into mass and change in temperature. Okay, mass of the body and change in temperature. So I can easily equate these two terms. Okay, I can easily equate these two terms because R1 minus R2, right? So I am just equating these two terms. So here mass is what? Mass means rho into A into distance. This is mass. Okay, this term. Like we can say change in velocity. So I am just writing this change in velocity as area into distance. So rho area into distance. So in place of mass, I'm just writing these things. Rho area into del x. Okay, distance. Rho area into del x into dou u. So just equate these two things. Okay, we can see this A will get cancelled. So I am just writing the remaining part here. After simplify it, you will get this part. Okay, so this is with respect to t and this is with respect to x. So I am just writing this x tends to 0 and this del t will be tends to 0. I am introducing two limits here. So limit del t with tends to 0 into this term, and again this term, like I am just taking the constant outside. So limit del x tends to 0 means this term. So this term, as we see, if del x is 0 means this term will become dou square u by dou x square. We know that. Okay, so this term I am just writing as h. So 1D equation, 1D heat equation, one dimensional heat equation will be dou square u by dou x square, which is equal to 1 by h of dou u by dou t, where here h is the thermal diffusibility. Okay, next I am just bringing the solution for this 1D heat equation. So usually if we find the solution means I am just taking u as xt. So for one derivation, this is one time derivative, this is two times. So one time, two time, I have got the equation, and one time with respect to t. So substitute these two things in this equation and separate it, and after that you will get a function like this, right? The same as in the wave equation. So I am just giving the k value in three cases. So case number 1 is what? Which is equal to 0. If I do so, d equal to 0. So I can easily write it as c1 plus c2 into x. This is e power 0, right? So it will be 1. So this term, and c will be like c3. So this is the term. But here this is not possible because this is independent to time. So this is not physically possible. So this one is, and just eliminate it. And the second thing is what? K is positive. So I can take k, which is equal to p square. So I will get d equal to plus or minus p here. So I am just writing the complementary function here. C1 e power pz plus C2 e power minus pz, and this term. So by combining these terms, I will get this thing. Here it is uncounted temperature. You can see here there is uncounted temperature. So this is one is also eliminated. Only the negative term will come. K is what? Negative. In the wave equation also we have took only the negative term. So K equal to minus p square means I will write this as in the form of, like, this one will be beta term, right? So I can easily write this like this. So CF functions, and you can see here if T is increases, temperature will be decreases, right? So I have got the equation like the solution like u of xt, this term, into e power minus h p square t. Okay, So I'm just applying the boundary condition and the initial conditions. We know that boundary condition is what? If x is 0, y equal to 0. If x is equal to L, y is also 0. This is the boundary condition. And initial condition is what? If y equal to f of x if t equal to 0. And y dash is equal to 0 if t equal to 0. These are the boundary condition, both for the wave and heat. Okay. So just substitute all these things here. So u of 0 t which is equal to 0. I'm just substituting. This is a x t. So I'm just substituting 0 and t. I will get C1 as 0. And L, if I substitute L and t, I will get this term. You can see C1 is 0. So C2 will not be equal to 0. So sin PL. So P is what? N pi by L. Right? So this is the thing. So I'm just taking this C2 as Bn. Okay, like this term as Bn. So in the solution you will get like C1 is, I'm just taking this as Bn. C2 will be equal to 0. So u of x comma t will equal to C1 is 0. So 0 plus C2 is what? Bn. I'm just taking the C2 as Bn. Bn sin P is what? N pi by Lx into e power minus h n square pi square e by L square into t. This is the term for u of xt, right? So I'm just wrote here. This is the term, and this term is like, so from this thing I'm just taking f of x as, I'm just leaving this e part. I'm just taking summation of n equal to 1 to infinity these two terms as f of x. So this is like half range Fourier sine series. Okay, so we can easily get this Bn value as 2 by L integral 0 to L f of x into sine pi n pi x by L into dx. Okay. So this is the thing. So we have got Bn and we can easily write this in terms of ut. Okay, Bn value is here and you can easily write this term Bn sine this term and e power. Okay, this is the thing. So I will bring one sum here, and this is the last sum, and after this sum the whole things will be finished in the differential equation. Okay, next we will move on to the next topic. So a rod of 30 centimeter long, so rod which has the length 30 centimeter, has its ends A, B, it has two ends, so kept at 20 degrees Celsius and 80 degrees Celsius. So at A it is 20 degrees Celsius, so at A it is 20 degrees Celsius and at B it is 80 degrees Celsius respectively until steady state temperature, prevails. The temperature at each end is suddenly reduced to 0. So these temperatures suddenly reduce to 0 and keep on. Find the resultant temperature Tn, and they have given one solution u of x1. Okay, taking x equal to 0 at 4. Okay, let's find the solution. We know the one dimensional heat equation, what? This one, right? And they had given steady state temperature. They have given one condition, right? Steady state temperature means it is independent of time, so we can put this thing as 0. So it will become dou square u by dou x square will be equal to 0. So d is what? 0. So we can write this in the function c1 plus c2, complementary function, c1 plus c2x, right? c1 plus c2x. So they have given length as 30 centimeter and end AB 2 degrees Celsius, like they have given 2 degrees, 20 degrees Celsius and 80 degrees Celsius. This is at beginning and this is at end. So start and end points. So I can easily write, if x equal to 0 it is beginning, right? And if x equal to 30, so x 0 comma t will be equal to 20 degrees Celsius. So 30 comma t will be equal to 80 degrees Celsius. This is like boundary condition, right? X equal to, like they have, so from these things I have found the conditions, not a boundary condition actually. So this is the condition. Okay, so just first apply these condition here and find the value c1 and c2. right? We know that u of x comma t is what? C1 plus C2x. If I put 0 here means this term will become 0, C1 which is equal to 20 degree, okay, because this term will be equal to 20, right? So I can easily get C1 as 20. If I put 30 and t means we know C1 is 20, 20 plus C2 into 30 which is equal to 80. From this thing I can easily get C2 as 2. So these two things just substitute in the equation. This is like f of x, u of x comma t. We know the boundary equation. Boundary equation is what? If x equal to 0, y equal to 0. If x equal to L, y is also 0. So I am just taking L as 30 here. So u of 0 comma t will be equal to 0. U of 30 comma t will be equal to 0. So substitute these two things in the solution of this equation. We know the one dimensional heat solution will be like this, right? So I am just going to substitute L equal to 30 here. Okay. Afterwards, I am just going to find this Bn. So Bn is what? From Fourier. Okay, from Fourier series we have got the Bm value as 2 by L integral 0 to L f of x sin n pi x by L into dx. We know that f of x is what? U of x comma t. So I am just writing this equation. So this one 20 plus 2x here as in the form of f of x, 20 plus 2x. I am just substituting L as 30 here. This is like uv. So we know that integral uv will be equal to u v1 minus u dash v2. So likewise it will go on. So I am just taking v as this thing and u as 20 plus 2x. U dash is what? 2. U double dash 0. So second derivative is not necessary. V1 is what? Sine. If we integrate sine means it will become cos, right? So cos n pi x by 30, right, into 1 by n pi by 30. If I integrate this cos, it will become minus sine, right? Minus sine pi x by 30 into 1 by n square, pi square and 900, because cos, and I am just integrating means the coefficient will become in 1 by the form, okay. Like if I integrate cos 2x means I will get minus of sine 2x by 2, right? So I am just writing this coefficient in the denominator. Likewise in the denominator, again in the denominator means it will become square. Okay, this is a term. Okay, so I am just writing all these terms here by substituting here u and v term. Okay, like this is a question. This is nothing but Bn. Okay, Bn which is equal to 1 by 15 into u and then u v1 plus, okay, because how it comes plus here means you can see here there comes minus, right, and in the formula also there is a minus, so it will become plus 2x into the term and this term. Okay, this is u dash, this is v2. After that just substitute 0 to 30. If I substitute here like these two terms, if I substitute 30 here means it will become sine cos n pi. If I substitute 30 here means this will become sine n pi. Sine n pi is what? 0. But cos n pi I can write it as minus 1 the whole power n. This is a formula, because as I told you cos pi value is minus 1. Cos 2 pi is 1. So minus 1 the whole power n. This is a formula here. So by doing so you can see here, first I am just substituting the upper limit. So 1 by 15. This one will become 20 plus 60 into this term cos of n pi will be minus 1 the whole power n into this term plus 0, because the sine term will become 0. This is upper limit. Minus lower limit is what? 0. So if I substitute here 0 means 20 into this term, cos 0 is 1 and this term will become 0. So this thing, so this is lower limit. Okay, so just simplify these things, like this will become 80, right? So I am just taking 20 these terms, this whole term as outside. So if I do so, 20 into 30 by n pi, 1 by 15 here. So here 4 into 20 will become 80, right? So 4 will be remaining one. If I took 20 means there is only 4 here. 4 into minus 1 the whole power n minus 1. Okay, so by doing so, bn we will get 40 by n pi into this term. This is the thing. So just bn in the equation and you will get the answer. Okay, so up to this the whole differential equation is completed. So thanks for watching this. Do watch the differential equation again and again. You will get the clear idea. I have completed all the syllabus in the differential equation, and another 2 or 3 more topics are there in the engineering equation. We need to complete the engineering equation. Do study with me and make it useful. Thanks for watching this. Do write your suggestions in the comments. I will respond for your suggestions. Thank you so much. Bye.